this video, we'll solve an example using the Fourier sine series. So first of all, the Fourier sine series of a function f of x on an interval, on a closed interval 0, L, is equal to sum as n equal 1 to infinity of b sub n sine of n pi x over L, where b sub n, those coefficients, are 2 over L, integral from 0 to L, f of x sine of n pi x over L dx for n equals 1, 2, and so on. So let's do the example below. Compute the Fourier sine series for f of x equals x squared for x between 0 and pi. So L equals pi. We'll consider that even if it's a closed interval, we'll still be able to say L equals pi. So let's say b sub n, it's equal to 2 over pi, integral from 0 to pi, f of x, so x squared, sine of n pi x over pi dx. So this really quickly is 2 pi, integral from 0 to pi of x squared. The pi cancels, sine of nx. And this is a problem that we should solve using integration by parts. So we have 2 over pi, integral from 0 to pi of x squared times negative cosine of nx over n prime dx. I'm actually using integral of fg prime is fg minus integral fg f prime g. So if I can write this function here as its antiderivative, so which function prime gives me sine of nx, then I can use exactly the formula above. So we get 2 over pi x squared cosine of nx over n, and there is a minus there, from 0 to pi, and then plus, right, because there is a minus but with this minus, 2 over pi integral from 0 to pi of x squared prime, which is 2x, cosine of nx over n dx. So if I evaluate the first one, it's going to be negative 2 over pi times pi squared cosine of n pi over n minus, when we evaluate at 0, this term is going to be 0, so that's gone, plus 4 over n pi integral from 0 to pi of x, and then we can put sine of nx over n prime. That's actually giving us cosine of nx. So we get negative 2 the pi squared 2 pi over n cosine of n pi, and then plus 4 over n pi parentheses and use integration by parts. So we have x sine of nx over n from 0 to pi minus integral from 0 to pi of x prime, which is 1, sine of nx over n dx. So it's pretty quick. Negative 2 pi over n cosine of n pi plus 4 over n pi, and then if x equals pi, we get pi sine of n pi over n, and then when x equals 0, we get 0. And let's not forget minus 4 over n pi, and then there is another n that comes outside, so n squared, and then integral from 0 to pi of sine of nx, which we can skip a step and say that's negative, so makes this one positive, cosine of nx over n from 0 to pi. So this is equal to negative 2 pi over n cosine of n pi plus 4 over n squared sine of n pi, and then plus 4 over n cubed pi cosine of n pi, and then minus 4 over n cubed pi. So really quick, if I have cosine, let's put them here, cosine of 0, it's 1. Cosine of pi is negative 1. Cosine of 2 pi is 1. Cosine of 3 pi is negative 1. So what we obtain is the same thing as if we had to evaluate negative 1 to the n for n equals 0, 1, 2. It's going to generate exactly the same thing. So we can say that actually cosine of n pi, every time we obtain that, it's actually negative 1 to the n. So then this is going to be negative 2 pi over n, negative 1 to the n. Now, here I forgot an n. Sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. So that means sine of n pi is 0. So this whole quantity is 0. So plus 4 over n cubed pi, negative 1 to the n, and then minus 4 over n cubed pi. So what we obtain here, it's actually b sub n. So going back to our problem, the Fourier sine series, it's equal to sum as n equal 1. Well, actually, I want to discuss a little bit more of this one here. Let's just take a look at, so let me write 2 pi, let me write it bigger. So 2 pi over n, negative 1 to n plus 1, n plus 4 over n cubed pi times negative 1 to the n minus 1. So if n is odd, or maybe let's start with n even. If n is even, like 2, 4, 6, this becomes 1. Minus 1, this whole thing is 0. So this whole thing is 0 if n is even. And if n is odd, we get negative 1 to the third. Negative 1, we get negative 8 over n cubed pi. So in other words, the Fourier series is going to be, so b sub n, well, it's not going to make much of a difference if the whole thing was 0 for even or odd, but this way we'll just leave it like that. And we are going to say that the Fourier sine series, now it's equal to sum, as n goes from 1 to infinity, of b sub n, so 2 pi over n, negative 1 to n plus 1, plus 4 over n cubed pi, times negative 1 to the n minus 1, everything times sine of n x. Okay, so now let's add some extra to this problem. Once we found the Fourier sine series, which I actually put in a purple rectangle, let's answer this question. To what values does this series converge? So I actually drew a picture of the function f of x between 0 and pi. It has open dots at the endpoints. And I want to find out to what function does this series converge. So how do I do that? Well, first of all, if we think of the Fourier series that we learned before, we were expanding our functions. But this time, because we have a Fourier sine series and our function is a sine, this function, I'm going to first draw an odd extension of the function that I have. What does that mean? Well, odd extension means to make this an odd, to have a graph that is symmetrical with respect to the origin. So this would be negative pi here and then negative pi squared. So this would be the point where we go symmetrically from the origin. So now we extended our function on the negative pi. So after that, I'm going to make a couple more extension of this function. So I'm just going to go now 2 pi and 3 pi. So 0, and then we just graph the same thing that we have here. And then it's going to be here. And then the same on the other side, negative 2 pi. So now it's easier to decide to what Fourier series converges. So the Fourier sine series is going to converge to this function. Well, let's say at negative pi. At negative pi, we have pi squared and negative pi squared. If we add those up and we divide by 2, we're going to get 0. So x equals. For x between 0 and negative pi, we have this graph here, which is x squared. For x equals to 0 is this point, so it's 0. For x between pi and 0, we have this graph that is continuous, so it's x squared. And for x equals pi, we have, for pi, we have this value plus this value, which are the opposite, divided by 2 is 0. And I have to make one correction. For 0, negative pi 0, the value that we actually have, or the function, is actually negative x squared.